Imagine looking back in time, not just a few years, but over 13 billion years to the dawn of the universe. In this cosmic nursery where the first stars and galaxies were just beginning to flicker into existence, you wouldn't expect to find monsters, but the James Webb Space Telescope just found one. Peering into the early cosmos, just 700 million years after the Big Bang, Webb focused on a galaxy designated QS01. At its heart, it found a supermassive black hole weighing in at around 10 million times the mass of our Sun. But the size alone isn't the whole story. This black hole is so massive, it accounts for a staggering 10% of its entire galaxy's mass. For comparison, the black hole in our Milky Way is less than 1/100% of our galaxy's mass. And even more surprisingly, its host galaxy is chemically pristine. It lacks the heavy elements or metals that are forged inside stars. This creates a huge problem for our standard theories. The fact that this galaxy is so unspoiled by metals means very few stars have lived and died there. So if there wasn't much star formation, where did this monster black hole come from? The traditional theory says black holes start from the collapsed cores of giant stars and grow slowly. But QS01's galaxy didn't have enough stars to even create the seed, let alone enough time for it to grow. Another idea was that a massive cloud of gas could collapse directly into a heavy black hole. But even this predicts a frenzy of star formation nearby, which would have polluted the galaxy with metals. Again, the evidence from Webb doesn't match. This leads us to a third, more exotic possibility: primordial black holes. These are not born from stars or gas clouds, but are hypothesized to have formed from extreme density fluctuations in the universe's first second of existence. They were born before the first stars and galaxies. They could act as the initial seeds, growing silently in the dark, gathering pristine, metal-free gas long before stars had a chance to light up the cosmos. The discovery of QS01 provides the first compelling observational evidence for this primordial origin story. It's a fossil not just from the dawn of galaxies, but potentially from the very first moments of the universe itself. It's rewriting the first chapter of cosmic history, telling us that giants may have walked among the infants. Thanks to Webb, we're learning that the early universe was far more dramatic and far more surprising than we ever dared to imagine. Every second, Earth is bombarded by cosmic rays, tiny high-speed visitors from outer space. They are the background noise of the universe. But sometimes, the universe doesn't whisper, it screams. On October 15, 1991, scientists recorded a scream so loud, so energetic, that it seemed to violate the very rules of reality. It was a single proton, and it carried the kinetic energy of a baseball thrown at 60 miles per hour. Imagine that power, the wallop of a fastball, all packed into a particle so small you could fit trillions of them on the head of a pin. On a clear night in the Utah desert, an array of detectors called the Fly's Eye experiment registered a flash brighter than anything seen before. When scientists ran the numbers, they were stunned. The energy was so impossibly high, it defied explanation. In the logbook, one physicist simply wrote a note, and a legend was born. It became known as the "Oh my God" particle. But this incredible discovery created an even bigger problem. You see, there's a cosmic speed limit. The universe is filled with a thick fog of ancient light left over from the Big Bang. As a high-energy particle travels through this fog, it loses energy. Physics dictated that a particle this powerful couldn't have traveled from a distant galaxy. It had to have come from our own cosmic neighborhood. But when astronomers looked, there was nothing. No exploding galaxy, no cosmic engine that could have possibly produced it. The particle's origin was a complete mystery. For decades, this remained a frustrating puzzle, but the universe kept sending us clues, and scientists built new, more powerful observatories to catch them. In 2012, deep beneath the Antarctic ice, they caught another ghost. This time, the detector was IceCube, a massive observatory threaded through a cubic kilometer of solid ice. And the messenger was a different kind of particle, a high-energy neutrino, so elusive it could travel through entire planets without leaving a trace. This one was so energetic, researchers nicknamed it Big Bird. But unlike the Oh My God particle, this ghost didn't arrive alone. As astronomers traced its path back across the sky, they found a smoking gun. At the same time Big Bird was detected, a distant galaxy had flared up. It was a blazar, a cosmic powerhouse where a supermassive black hole at the galaxy's core shoots a jet of particles directly at Earth. For the first time, scientists had a prime suspect for one of these ultra-high-energy messengers. While the blazar is the likely source for the Big Bird neutrino, the origin of the original, far more powerful Oh My God particle remains unsolved. Each detection is a new chapter in a cosmic detective story, reminding us that the universe's most violent events are writing messages across the sky, and we are only just beginning to learn how to read them.